write something important, and you grab a marker, pop off the cap, and nothing. Just a sad, squeaky ghost of what used to be vibrant ink. Yeah, we've all been there. But here's what's wild. Before that marker betrayed you, it went through an absolutely ridiculous journey. And I'm not talking about the trip from the factory to your junk drawer. I'm talking about its birth. Because making a marker, it's way weirder than you think. So buckle up. We're about to go deep into the secret life of markers, and I promise you'll never look at a Sharpie the same way again. Let's start with the most boring part of a marker, the plastic tube. Except, it's not boring at all. See, that little cylinder holding your ink isn't just any plastic. It's usually made from polypropylene or polystyrene, basically the same stuff as yogurt containers. But here's the kicker. It starts its life as tiny plastic pellets. Like, imagine a massive warehouse filled with what looks like colorful fish eggs. That's where your marker begins. These pellets get dumped into a hopper, which is a fancy word for big funnel, and then melted down at around 400 degrees Fahrenheit. That's hotter than your oven can go, by the way. The molten plastic then gets injected into barrel-shaped molds at insane pressure. We're talking thousands of pounds per square inch. And here's my favorite part. The whole injection molding process takes like 3 seconds. 3 seconds to create the shell that'll hold your grocery list for the next 6 months. The factory spits out these barrels faster than you can say, permanent marker mishap on the couch. Okay, now for the good stuff. The ink. This is where things get chemically chaotic. Marker ink isn't just colored water, my friend. Oh no. It's a carefully balanced cocktail of dyes or pigments, solvents, and resins. Think of it like a recipe. Except if you mess it up, you don't get a bad cake. You get a marker that either won't write or will literally never stop bleeding through paper. The solvents are the carriers. They keep everything liquid and help the ink flow. For permanent markers, they often use alcohol-based solvents. That's why Sharpies smell the way they do. You know that smell. We all know that smell. Some of us enjoy that smell a little too much, but we don't talk about that. For washable markers, water-based solvents, much less dramatic, much more parent-approved. The colorants are where the magic happens. These can be dyes, which dissolve completely into the liquid, or pigments, which are tiny suspended particles. Pigments tend to be more light-fast, meaning they won't fade as quickly in sunlight. Dyes are usually more vibrant, but can be drama queens about UV exposure. And then there are resins. These help the ink stick to surfaces and dry properly. Without them, you'd just be smearing wet color around forever like some kind of kindergarten nightmare. All these ingredients get mixed in massive vats, sometimes hundreds of gallons at a time. Industrial mixers churn everything together until it reaches the perfect consistency. Too thick, your marker clogs. Too thin, it bleeds everywhere and your 7th grade notes become an abstract art piece. Now let's talk about the tip, say the business end, the nib. This is the part that actually touches the paper, and it's usually made from felt or some kind of porous plastic fiber. But calling it felt makes it sound cozy, like a craft project. In reality, it's engineered fiber that's been compressed and shaped with ridiculous precision. For fine point markers, manufacturers create nibs by forming fibers into dense, bullet-shaped tips. For chisel tips or brush tips, different molds, different fiber arrangements. Some tips are layered like a tiny fiber lasagna to create the perfect flow rate. And here's something that'll blow your mind. The nib has to be porous enough to let ink through, but dense enough to maintain its shape after thousands of strokes. It's basically a high-performance sponge. The nibs get cut to size, inspected, because a wonky tip ruins everything, and then prepared for assembly. Some factories produce millions of these per day. Millions. There are more marker tips being made right now than you could use in 10 lifetimes. Here's where it gets really interesting. Inside most markers, there's a core, basically a fiber rod that runs the length of the barrel. This acts like the marker's circulatory system. It holds the ink and feeds it steadily to the nib through capillary action. Yeah, the same physics that lets plants drink water. These cores are made from synthetic felt or foam, and they're absolutely saturated with ink during assembly. Picture a conveyor belt of these fiber rods getting dumped into vats of colored liquid like some kind of office supply baptism. The amount of ink absorption is calculated down to the milliliter. Too much ink and the marker will flood when you first use it. Hello? Instant blob on your paper. Too little and it runs dry before you've finished labeling your third moving box. Now comes the part where everything comes together. In most modern marker factories, assembly is automated. Robotic arms moving with scary precision, slotting components together at speeds that make you dizzy. First, the saturated core gets inserted into the barrel. Then the nib gets pressed into one end, sometimes both ends for dual-tip markers. The cap gets produced in a separate molding process and eventually snapped on. Some markers get additional plugs or seals to prevent the ink from drying out. Quality control happens at multiple stages. Automated systems check for leaks, test ink flow, verify cap fit. Because nobody wants to buy a 12-pack of markers where the green one is secretly dead on arrival. The whole assembly process for a single marker, usually under 10 seconds. You'll spend more time looking for a marker in your drawer than it took to make the thing. So there you have it. Your humble marker, the one currently rolling around in your bag without a cap, went through injection molding, chemical mixing, precision fiber engineering, and robotic assembly before ending up in your hand. It survived temperatures that would melt your face, pressures that would crush a watermelon, and quality control tests that rejected thousands of its siblings. And what do we do with this marvel of manufacturing? We lose the cap. We let it dry out. We use it to label one box and then never see it again. But hey, at least now you know its story. And maybe, just maybe, you'll put the cap back on next time. Probably not though. Thanks for watching.